Bjoern. I'm in the data science engagement group at the National Energy Research Scientific Computer Center, NERSC, at Lawrence Berkeley National Laboratory. Next slide, please. Right, so Exascale systems are supercomputers with a performance in excess of 1 exaflops. And I just want to put this in perspective. I thought it's like about 10 million laptops, so like a bit more than the Bay Area, all the laptops combined. And we heard before, these machines, in order to meet their performance goals for a certain amount of dollars, certain amount of power, they will include a diverse set of accelerators. The first round will include GPUs, but further down the line, there will be TPUs or ASICs or FPGAs coming. These computers are heterogeneous today, so it's a lot of hurdles, but coming down the line, it will be even more, specialized hardware, specialized nodes for different purposes. You have different storage I/O tiers, you have different vendors. All these components add up and makes it even more difficult to understand these systems. Then, and you even have a mission to make all these computers different. And then we are also different from cloud providers, of course. So this makes portability a challenge. And of course, on the same system, we're supporting users from very diverse science communities, and each have their own codes. Each code has different footprints on the system, but they do share the same system. They do share the same resources, because that's one key defining parameter of a HPC system, because you kind of share components. And just below, I just put a few, like the first two on the top 500. So it's the Fugaku and Summit. You see already that this is different processors, and Summit comes already with an accelerator. And the first Exascale machine in the DOE from DOE that will hit the user space will be Frontier, so and that will be 1.5 exaflops. You see that all different processors and different vendors and so on. Next slide, please. This is a quick overview of all the pre-Exascale systems and Exascale systems, and we can take a closer look maybe in the breakout. But I want to go into the challenges. One time's up. Thank you. All right, so I put on just a few topics, and I brainstormed a bit with my group and also with our advanced technologies group. So what are challenges to come? So basically, there's the typical HPC challenge that these systems will have like hundreds of thousands of nodes, and there's limits to how much the scheduler and policies will allow you to schedule smaller kinds of jobs. Then there will be specialized hardware coming. You have to, as the speaker before me told already, how do you handle these dependencies? How do you profile these? And one particular benchmark that might come into play in the future is what's the ecological footprint of your entire workflow? And how efficiently did you manage to use the resources at an HPC center? Next slide, please. And then there's more common ones. This is HPC centers are not cloud providers, so there's like the whole system might undergo overall maintenance. That it ages, so nodes might fail. So how do your workflows work with these events? What do you have like some automated failover? Do you have some kind of detection in this workflows? Can you just go to a different machine? Can you make it larger than this one HPC systems? Then the next topic is how do you deal with moving the data to the compute nodes? They might have like on node flash. You have my different storage tiers. They're globally accessible at each HPC center. And then also, how do you include the data sources from the outside, like experimental facilities, observation facilities that want to pump data into an HPC center to do the analysis? Can you just make it one big workflow with your tool? And the last bit is, of course, how does your tool work with the community? Can you convince people to use your tool on your system? Does it work? Does it not, make a whole bunch of small files and make life hard for other people on the system that have like the performance degradation on the storages? And the last but not least, and a more important topic that came, there's only a limit to how much we can express, scientific user groups at facilities, at HPC facilities. And can your tool, be like an intermediate step? So can you basically have your own authentication and your own subgroups or whatever that use your tool, or can you share your workflows across your group so that it's not just a per user basis that deploy your workflow tool?